The 10,000x computation tax. Running a standard 7 billion parameter model through a zero-knowledge circuit currently carries a computational overhead of roughly 10,000 times compared to standard inference. While marketing teams suggest this enables total privacy on public clouds, the actual math shows we are nowhere near real-time performance for consumer-grade hardware. The primary bottleneck is not the model weights themselves, but the massive number of constraints required to prove every single matrix multiplication in a transformer block. Recent data from the May 2026 ZK-ML Alliance report confirms that even with optimized proving systems, generating a succinct, non-interactive argument of knowledge for a single token takes seconds, not milliseconds. This massive latency makes standard chatbot applications impossible under current architectures, proving the attention mechanism. To understand why the overhead is so high, look at the attention mechanism's arithmetic circuit. In a standard ZK-LLM setup, the cloud provider must generate a proof that they correctly performed every dot product and softmax operation without ever seeing your raw input. This requires converting nonlinear functions into massive polynomials that a verifier can check in constant time. The paper released by the Zurich AI Institute last week highlights a specific failure point: quantization. When you quantize a model to 4-bit to save memory, the zero-knowledge proofs actually become more complex because the arithmetic circuits must handle the bitwise logic of compressed weights. It is a paradox where the optimizations that make LLMs fast for humans make them significantly slower for cryptographic verifiers. The scaling laws for proving complexity are currently working against us. The ASIC hardware pivot. General-purpose GPUs are fundamentally inefficient at the specific field operations required for ZK proof generation. This is why the June 2026 hardware benchmarks from specialized startups show a 50-fold increase in throughput when switching to dedicated ZK ASICs. These chips bypass the standard CUDA overhead and focus entirely on large-scale multiscalar multiplication and fast Fourier transforms. However, a devil's advocate view suggests this creates a new centralizing force. If you need $1 million rack of specialized silicon to verify a query privately, the cost-to-benefit ratio for most developers stays firmly in the negative. We are seeing a split in the industry where high-security financial and medical tasks use these dedicated proving clusters, while general developers are stuck with slower, software-emulated proofs. This hardware gap determines the actual boundary of private AI. The signal under the noise. The move towards ZK-LLM is less about universal privacy and more about the shift toward verifiable integrity in non-custodial environments. Based on the performance bottlenecks in the attention mechanism and the current high cost of ZK ASIC hardware, the thesis that we will all use private clouds by next year is mathematically unsupported. Instead, the real implication is a transition to hybrid inference. Builders will likely use standard secure enclaves for the bulk of the LLM computation, while reserving zero-knowledge proofs for the final verification of high-stakes reasoning steps. This allows a dev to prove that a specific regulated model was used to reach a conclusion without revealing the underlying proprietary data. It transforms ZK-LLM from a privacy blanket into a compliance tool. The most critical metric to watch over the next 6 months is the adoption of recursive snarks, which could finally allow us to aggregate multiple inference steps into a single, cheaper proof for audit logs. Subscribe for more.